For years, John wasn't really just building software. He was actually building understanding. What might have looked from the outside like just a chaotic series of fragmented experiments or endless redesigns was actually a long, quiet incubation period. He was absorbing absolutely crucial observations about systems, about the psychology of deep work, about technical constraints, and fundamentally, about the very nature of creation itself. So this explainer documents a real masterclass in systems thinking. It's the story of how an overly complex vision was relentlessly stripped down to a perfectly structured, executable reality. We're diving into the evolution of the project known as Exocore 26. It's an amazing journey from a highly ambitious, completely theoretical, agentic AI dream into a highly practical, distributed production system. Think of this as a documentary on constraint-driven engineering, exploring exactly how an architect named John took a set of incredibly harsh limitations and transformed them into his absolute greatest advantage.
All right, let's start with Chapter 1, the Agentic AI Dream.
Taking a look at the master blueprint, I want you to focus your attention right over on the far left column, Phase 1. Exocore 26 was initially conceived as something genuinely vast. We're talking about a massive recursive intelligence. John envisioned this central Hermes core engine acting basically as the brain, directing a whole multitude of subagents. It was designed to look and act like a digital organization where AI agents would coordinate with other AI agents. The original goal? To literally build an autonomous AI company.
Now, the philosophy driving this whole design was wildly ambitious. Be better than the best. John didn't want to just copy existing systems. No, he wanted to build an autonomous architecture capable of taking incredibly complex goals, breaking them down, running recursive simulations to find the absolute best path forward, and then completely autonomously executing the work. And honestly, that's incredibly attractive in theory. I mean, you just feed the system a prompt, sit back, grab a coffee, and watch a digital workforce build your empire. But as with pretty much all grand theoretical designs, this vision was about to have a very, very hard collision with reality.
Which brings us to Chapter 2, Reality Meets Hardware Constraints. 4 gigabytes. That wall was exactly 4 gigabytes thick. That was the absolute hard limit of RAM on John's Dell Inspiron laptop. Now, the hardware didn't care about his grand vision of recursive AI simulation. It simply enforced its physical limits. You literally cannot run an omnipotent digital workforce on a machine that struggles to even open a dozen browser tabs. The system would just crash, period. This is the moment where so many projects just die, right here. The creator becomes way too attached to the original vision, starts fighting the constraints, complaining about the hardware, or just puts the whole project on hold until they can, afford a bigger, better machine. But John did the exact opposite. He adapted. Instead of trying to force the machine to become something it wasn't, he actually began redesigning the entire system around that 4 GB limit that existed in front of him. The goal completely shifted from trying to build an autonomous AI organization to creating a production system that works right now. So let's look at Chapter 3, Distributed Human-Centered Workflows. Tracing the timeline here really reveals how he overcame that massive limitation. Starting with the 4 GB RAM limit in Phase 1, John enters Phase 2 by literally splitting the workload across multiple weaker devices. He created a distributed system based entirely on the separation of roles. And this then naturally matures into Phase 3. The system is no longer trying to be this magical autonomous AI, but rather a human-augmented automation network. The decoherence of that original dream, well, it actually resulted in a highly structured, wonderfully functional reality. This device node topology perfectly illustrates that adaptation. John basically stopped viewing his devices as isolated, inadequate little machines. Instead, he turned them into highly specialized nodes within a network. Just break it down for a second. The TCL phone acts purely as the capture device for voice, text, and raw ideas. Then, the Samsung phone steps in as the coordination device, a single source of truth routing all those tasks. And finally, the Dell laptop, totally freed from trying to do everything at once, becomes the dedicated build device, strictly for implementation. The architecture completely shifted from being agent-centric to being role-centric. Just like a real-world factory, not every machine does everything. But perhaps the most profound evolution here wasn't actually technical at all. It was philosophical. The human being, John himself, returned to the very center of the system. In the old design, the AI was the core. In this new workflow, it starts with human intent, flows through capture, structure, and build, and then always returns back for human review and documentation. The system stopped trying to replace the creator and started trying to amplify him.
The AI suggests, it accelerates, and it implements. But John decides, directs, and injects the actual meaning. And let me tell you, this dramatically reduces system complexity while massively increasing reliability. Moving right along to Chapter 4, the 3 output factories. Looking back at the master blueprint, notice those output streams sitting there in the bottom right corner. To make a factory actually work on a 4GB laptop, John had to abandon heavy, resource-draining graphical tooling, things like Android Studio. Instead, he shifted to incredibly lightweight, repeatable pipelines. We're talking local, efficient LLMs like QN, using VS Code, and running command line execution through Gradle. This right here is the absolute hallmark of a systems builder. Beginners build products, but system builders, they build production systems. And that one underlying engine now powers 3 distinct pillars, or what we call output factories. First, you've got the app factory, transforming an idea into code, building it, iterating, and publishing actual Android apps. Second is the YouTube factory, taking the history and the experience of development, scripting it, and turning it into video content. And third, the ebook factory, transforming deep research and ideas into structured, published assets. 3 completely different output streams, all powered by one highly refined, perfectly distributed engine.
Let's wrap things up with Chapter 5, From Theory to Implementation.
The contrast between these 2 paradigms is just striking. On the left, we see the old way, a complex, heavy, and ultimately unsustainable network of simulated agents. It was a beautiful dream for sure, but a practical nightmare. Then on the right, the new way, a simple, efficient, and wonderfully repeatable intent-driven pipeline. It totally shed the theoretical complexity of recursive AI and replaced it with real, tangible, practical capability. Now, what's really crucial to realize here is that the core mission never actually changed. John's ultimate goals, achieving personal freedom, generating passive income, and committing to 35+ hours a week of true deep work, remained identical all the way from Phase 1 right through to Phase 3. What evolved was simply the strategy. He shifted from trying to simulate success to actually implementing it, from managing wildly complex systems to mastering repeatable, rock-solid pipelines. Ultimately, Exocore 26 is no longer an attempt to build an army of digital agents. It is a distributed production ecosystem that takes human thought and effectively, reliably turns it into reality. Every single abandoned approach just revealed a better one, leaving us with a powerful realization straight from the architecture itself. I don't need thousands of agents. I need the right tools, the right workflow, and the will to build. Which leaves a final, pretty important question for all of us to consider. What harsh constraints in your own work are you currently fighting that could actually serve as the exact blueprint for your next great architectural breakthrough?